Awesome. Okay, so I don't have any fun AI stuff to talk about, but I am, since I work at Jam and we build a browser extension, I thought I'd talk about a browser feature that caused or illuminated an extension bug that we found. So hopefully you'll learn something about browsers you didn't know, and then I'll show you how we fixed something. A really brief primer on just how extensions work, because it's going to be kind of important to understand for how the bug works. If you do know how extensions work, you will understand that there's a very, very superficial overview of how extensions work, but bear with me. But basically, there is a background process that's always kind of running when your browser is open, and this is the thing that can receive a bunch of events about what happens in the browser if you are opening a new tab or closing a tab or a page loads or whatever it is. What you can also do by writing an extension is you can add scripts to pages. And so that's something that we do at Jam. And then those scripts live, and then they need to kind of communicate back and forth and pass data around. So it becomes complex pretty quickly, and there's a lot of stuff going on. For the purposes of this illustration, there's two browser events that are really interesting that'll explain how some of this stuff works. One is the onCommitted event and an onCompleted event. And so what this means, onCommitted is basically the browser saying, hey, I am about to load this page. I haven't loaded it yet, but it's about to happen. This is when we say, okay, we should add some scripts to this page for various Jam features. And based on what features you want to enable, we'll decide which scripts to add. And then the onCompleted event is basically the equivalent of the DOM loaded event. It's like the page is now loaded and like everything's executing and should be available. So what was the problem that we saw? We kept seeing in our logs the logs were suggesting that we were adding the same script to the same tab multiple times. And this was really confusing to us because we have a really good guarantee that onCommitted event only fires once for when a page is about to load. So it was just it confused the heck out of us of like what was going on. And so when we were debugging this, we found out about this browser feature called BF cache. And so what is BF cache? Back forward cache is what it's short for. It kind of makes sense. But what that is like if you're navigating forward and backward in your browser, there's this additional cache layer. So you've got your HTTP cache, which can cache all your browser assets and images and stuff. And then they wanted to add this additional cache layer to make the performance of loading a page for repeat navigations much faster. So if you think about like going to google.com and searching for something, and then you're clicking on the first result and you're like, nope, not what I want to go back. Second result, not what I want to go back. That reverting or going back to that search page is where this can come in really handy. And so what is it doing behind the scenes? It's really snapshotting the entire page in memory, including the JavaScript heap. And so what that means is all of the timers, all of your promises, everything's paused. All the pending tasks in all the JavaScript queues are paused. And it basically, for illustration purpose, is the equivalent of like opening the DevTools panel and like clicking the pause button. Everything just halts. And so that's really handy because then it can resume. If you're navigating really quickly between pages, it can just take that and start resuming and run, and like the page feels pretty much instantaneous. And so that was fun, but like how is this related to the bug that we ran into? And so going back to this illustration, so like this is not quite the full picture now. So what can actually be happening is in each of those tabs, there might be actually multiple documents that are related to that tab. If you're navigating quickly, you've got like at least one, maybe a couple that are these frozen states. And so our code wasn't smart enough to realize this. And so what we didn't want to do, or the problem we were running into, is like we didn't know that this third document that already had Jam on it. So we'd inject add our scripts again, and now we'd have two instances of the script. And like as responsible engineers, like why waste that memory and that CPU on the client machine or on the user's machine? And so we want to fix this bug. So let's walk through the options that we have and how the browser APIs work that allows us to figure this out. So the onCommitted event, like as mentioned before, the tab is about to start loading. In that event that we get, Chrome conveniently gives us this transition qualifiers object, or array actually, and one of those things is forward back as one of the values. And so this is an indication that the user used the navigation events, or they're on their computer, command left or right or whatever, initiated the navigation event via going forward or backwards, which means that this page load that's about to happen might be eligible for this BF cache feature. The other thing that we get is this document ID. And the document ID is a UUID that the browser assigns for that specific page load, for that document that's being loaded, which turns out to be really handy. So if we walk through the no BF cache and the BF cache examples, so if you think about opening a tab, go to example.com, that event fires, we get this document ID of ABC. You then go to your URL bar and type in google.com, you get a different one, and now you hit the back button. Let's say example.com has like a no cache header specified, and so it's not eligible for BF cache, and so it'll load it again, and you get a different document ID. It's going to load it from scratch. With BF cache, all the same thing happens, except when you hit the back button, now all of a sudden, we have the same document ID, which is kind of cool. Didn't realize that before. We weren't looking for that information. And so now we actually know that the browser is going to reuse this frozen page or this frozen document. And so if we zoom in on this event, how we actually solve this bug is state, complicated state. It's fun and not fun at the same time. So during this on-committed flow, in the normal flow, what happens is if we don't see that back forward flag in the event object that we receive, we just add the scripts and life goes on like normal, like we were doing before. But now when we see that, we can actually say, okay, we don't have enough information yet to answer the question of whether that document is frozen. And so what we do is we kind of basically defer making a decision on whether we should add our scripts to that page until this other event happens, which is this onCompleted event, which is the DOM load event. Like we know that if there are scripts on that page, they should be running by now. And so then what we do is we can actually look back at whether or not we have state that represents that we loaded that script. So there's a lot more detail that happens in these dotted lines, but basically we keep track of when we add, like this timestamp of when we added a script, and also a timestamp of when that script did a client hello and said, hey, I exist. And so we do that for the tab ID and the document ID combo. So as the same tab may have multiple documents in it, we can keep track of those documents individually, and then we can compare or know if that timestamp exists. And then we kind of know that the script should be on the page, or anyone that is relevant should be on the page. It can get a little bit deeper, but I'll try to avoid going into that because there's promises and race conditions. And then if you think about being Danny and smashing Command R a whole bunch or going back and forth really fast, the races get really interesting because everything is asynchronous and promise-based, and then once you're dealing in milliseconds, you can have stale data very quickly. So we found that it was really important to keep track on the most granular level that we can of what the state is for this little tiny thing of knowing if the browser is utilizing this feature, which is completely opaque from the user perspective, and rightly so. They shouldn't have to need to know. And so that's kind of it. And if that sounds interesting and you like browsers and events and stuff like that, then let's chat.